Okay, so this is module 12 homework. My apologies if you hear the fan blowing, but they turn off the air conditioning. I guess to save you as the taxpayer's money, but it means that because I'm working at 3:46 in the morning and I'm at the office, there is no air conditioning, so a fan is needed. I want to talk to you about the module 12 homework here. Which I can see I need to change the due date for. Okay, so I just want to talk briefly about these, just to kind of help you do these faster. So for this first one, this is basically definitional of what a correlation coefficient is. So remember that the correlation coefficient, what it is that it's measuring the statistical relationship between two variables. It ranges from -1 all the way to 1. If it's -1 or 1, that's basically the strongest agreement you could have between the x and y variables. If it's 0, that's complete disagreement. So if this is the case for linear relationships between the two, x and y, that we're describing them with having a linear relationship, think of that line as having a slope, right? But that the correlation coefficient isn't necessarily the slope, but that there might be some commonalities between them. Hopefully that helps you. You can watch this video too. Over here we've got blood alcohol level in beer. And what we're asked here as you read this is whether if you drink the most number of beers, whether you would have one of the highest blood alcohol levels. Is that, what would happen if I found that someone drinking 9 beers had a 0.15? Would that increase the strength of whatever linear relationships exist here or weaken it? Well, if it's 9 and it's 0.15, it certainly reinforces the linear relationship that exists, which basically would mean is that it's increasing the strength of that association. I'm not trying to solve it for you, but I do hope it helps you understand what's going on here. We would have seen decrease if it was 9 and like way down here. That would have weakened it, decreased. Stayed the same. That's a little bit harder to tell. I mean, that could be like something a little bit weaker than a 0.15, and it would be kind of in this line here. Because I had 9 and 0.15, it's actually a little bit above the trend line. Now we've got body weight and health weight. And we're given a regression, and we want to know which one of these is true. So let's just start here. Slope estimate would not change if body weights were used in pounds of kilograms. That's not true, because the numbers would be different. So the slope estimate would have to be different because 1 kilogram is 2.2 pounds. So the slope estimate would be 2.2 times higher as a multiple, because pounds are more than kilograms in terms of being a number. 1 kilogram increase in body weight causes 4.034 grams in heart weight. Well, in this case, it's actually the opposite way around here, because we're doing body weight for Hartgram. It's all in nature of what's our dependent versus our independent variable. And basically for this part it's switched. Correlation coefficient would not change if we were to use body weights in pounds instead of kilograms. So correlation coefficient is different because correlation coefficient is just the percentage difference deviation of the x versus the y variable. If it's a percentage difference, what you use as a measurement really wouldn't be affected. So this is true, but let's just look at the last one here. Body weight is not a significant predictor. But it is. We know it is because we actually can see that in our coefficients here for the regression analysis. So I guess in this case I have given you the answer, but hopefully helps you understand it a little bit more too. Here, without answering this here, there's really not much you can really say about this. This is a scatter plot indeed. One of these is true. That's what I'll tell you. One of these is true. I'm trying to compensate for the fact that I kind of gave you the answers to the other one. So I'm being a little bit deceptively non-committal there. So here, we're asked to say a little bit about what the correct linear model would be. Well, in general here, we see kind of a negative relationship existing. So because of that, we can already get rid of these two options because it's plus and plus. So now we're really stuck with 3.7 versus 6.7. And what we're going to be able to see here in terms of the coefficients for this regression analysis, you need to think about what is determining the y-intercept, because that's really going to be your difference in between you knowing whether it's 3.7 or 6.7. Again, I'm trying to be a little bit deceptive or not tell you completely what the answer is, just to kind of make you do a little bit of work here. I like this one because it's all about Hawaii. Well, it's not all about Hawaii. But basically we have three terms here that it's important to understand to be able to answer this question. That would be what's an outlier, what is influential, and what has high leverage. So outliers are data points where the data point does not even follow the general trend of the data, meaning it's just out there. The model does not have a good explanation for it. Influential, let's do high leverage. So outlier doesn't follow the general trend of the data. High leverage would be it totally, completely follows the data. In fact, it extremely follows it, meaning it's on one of the tails of that linear relationship. So something like DC. DC would have a lot of leverage. It's an extreme predictor with not many white people, but a lot of female households. Now, Hawaii is just out there, meaning it is an outlier, but we actually don't have an option where Hawaii is an outlier. Now, that's where we need to know what the term influential means. When something is influential, that means that it's influencing or affecting the slope coefficient or parts of the regression analysis. Both outliers and high leverage data points do have that influence. So it turns out that there's just not a lot of white people in Hawaii. Just the nature of what we are as a state. And so consequently, if Hawaii was located on the mainland, we might have more white people, and maybe we'd have the same number of female households. Where this data could become more interesting would be if we didn't do states, but let's say we did other oceanic islands and archipelagos, right? We might actually then be able to see, instead of percent white, I mean, we could even keep it percent white, but maybe we could make a very general category of Asian, or we could try to break it down into specific countries of origin. Okay. Here, I just made my life easy here. I went to Social Science Statistics, socialsciencestatistics.com. I typed in, these values for my linear regression calculator, typed in all those x variables and y variables, and down here I then found out what my y is and what my b is and my a. Same thing for the next one. I have data points here. Here I put them in socialsciencestatistics.com. I put them into my Pearson correlation coefficient calculator. Typed in the x values, typed in the y values, and I got my data here. And you should be able to answer the rest of this with that data. Here, you can actually just type in the you can just put in the numbers into the equation. So here, in this case here, I would have negative 0.848 plus, negative 0.848 times 12 plus 32.636, and that's going to equal my number right here. So depending on what your things are here, you can just set this up as a regression equation. Here, you just need knowledge of your scatter plots to be able to kind of tell what these correlation coefficients, how that would connect to each of these pictures. Sorry, I printed it out longhand beforehand here. Here, dude, this is pretty easy. In your TI calculator or whatever, just take the square root of 0.25 and you'll get your R. Because, right, R squared is the square of R. So just take the square root of it. You've got some bivariate data here. It's pretty messy. Certainly not linear. Is that then appropriate? Heck no. Oh, I'm going crazy there. Okay, so I've got a equation again. Put that number in for x, solve for y. Who says statistics has to be hard? Now I'm doing the opposite. Take the square of this, and that's your R squared. Square it. And for this bivariate data set, two variable data set, you're just going to have to type these numbers in. You need to get a good sense of what the correlation coefficient is. You might want to graph it out. So maybe you could even just copy and paste this into Excel and then graph it out and see what the data points look like. Is it a straight line of some kind or not? If it's not a line, if it's curved or anything like that, then it won't be. If it is a kind of a line, then it is. And this you should just be able to talk about based on your understanding of what regressions are. Okay, I hope that helps at least enough for you to be able to work out things more efficiently.